Let's start with the rapid fire round. At what age do you want to retire?
65.
How long does it take you to get ready in the mornings?
Ages, because I need to prepare my 3 kids.
Most embarrassing moment of your life?
Lots of them.
You can always pass. Favorite color?
Blue.
What time of day are you most inspired?
Late at night.
How many hours of sleep can you survive on?
I can survive with 6 hours.
Okay. Fill in the blank. An upcoming aviation trend is blank.
Sustainability.
The city in which the best kiss of your life happened.
Toulouse, France.
Pick one, Mark Zuckerberg or Elon Musk.
None of the two.
The biggest mistake of your career.
Pass.
How do you relax?
Listening to music.
How many cups of coffee do you drink per day?
None.
A habit of yours that you hate.
Overthinking.
The most valuable skill you've learned in life.
To be agile.
Your favorite Netflix show.
Netflix. Breaking Bad.
One word description of your leadership style.
Relaxed.
Top priority in your daily schedule.
Connect with people.
Memorable career milestone.
Completing my PhD.
A recent business innovation that caught your eye.
Digital twins for operational disruption simulation.
All right, so that was the end of the rapid fire.
All right, cool.
And the rest of the questions you can answer with as much time and ease as you like. All right, so question one, the long form questions. You have a diverse background with experience in both academia and the aviation industry. Can you share some key insights from your journey, including how your academic experience in computational aerothermodynamics has influenced your role in leading technical innovation in Dutch Airlines?
Yes. Quick story. I started studying mechanical engineering, and throughout this journey, I loved aerodynamics, I loved thermodynamics, so I started thinking, what's the next step? And this is a moment in time where I decided that I want to follow a career in aerospace or aviation, like traveling and flying. For me, it's something that I really like. It gives this kind of sense of freedom to me. I did a PhD after my first degree on computational thermodynamics with a specialty in aircraft engines. And back in the days, I was thinking that I should follow a career in aerospace, basically like manufacturing, like working with the plane manufacturers. However, life had other plans for me, and I switched to aviation at some point. However, let's say all those skills I've learned during my PhD and my studies, I consider them very valuable. Why? Because knowing how systems are designed, that makes you also understand how systems operate. I entered this kind of AI and data science space with a prior knowledge of the systems themselves, and that's something that I find very useful on a daily basis. In fact, working with those systems from an AI perspective it means that you have to deal with the way they work. And I had this prior knowledge and this kind of prior career that helped me a lot. However, I haven't decided yet whichever I like more, academia or the industry. I like them both equally, and that's why I keep switching, or at least I always keep a part of the two during my career. So, well, I currently also work as a visiting academic at the same time with my industry career.
So how do you balance the need for innovation with the operational demands of a large airline like KLM? And what strategies have you found effective in driving innovation within such a complex organization?
Yeah, that's a very good question. Companies like KLM and in general airline companies are, let's say, they have all kinds of different departments under the same roof. So think about a company that has to basically deal with have passenger operations, commercial operations, flight operations, planes need to fly, ground operations, they need to be serviced on the ground, catering, maintenance, I can keep going, HR, and so on. So basically, in this kind of setting, it's, you can get inspired a lot, but you can also get distracted usually. So you need to somehow isolate sometimes yourself from this kind of very fast-paced operating environment and try to think, well, what I could improve in this kind of environment, because you see that for operational environments, there are all kinds of deficiencies here and there. I mean, things always go the wrong way, and then you need to react on that. And I think the biggest innovations in aviation will come from the space where you can improve this kind of operational coordination between different departments and within the departments. And that's also that's a practice that enhances sustainability, because in fact, well, whatever deficiency you have when it comes to the way that planes fly, the way that planes maintain, the way that planes are handled on the ground, that means usually extra time, extra resources, extra emissions, and so on. So basically, optimizing aviation and airlines specifically, it's by definition a sustainable practice that I'm very interested at.
Could you give us some examples of the most exciting emerging technologies, aviation, that you've been involved with, and how they're impacting the industry?
Yeah, so lots of things are happening in aviation these days. And again, there's lots of discussion about how we can make the industry more sustainable. So in that sense, AI plays like a pivotal role in making aviation more sustainable. I can give you some examples. Planes, they fly for, let's say, many decades now, but the way we optimize the routes on the sky, or the way the practices we follow while flying, like the fuel consumption, can, for example, be improved and optimized by using AI. That's a very interesting space. Also, you can use digital twins, and what is digital twin is basically a set of different technologies that work with data. So you need to have this kind of real-time data feed. And then, on top of that, you add layers that can be predictive, that can monitor different parts of the organization, assets, and so on. And those layers, I'm talking about IoT, things like that. So by developing digital twins that can help you monitor your operations and even predict disruptions, predict things that might happen in the future, because again, things can always go wrong. It's a very stochastic environment. In this kind of setting, that's a very interesting technology. A last example of a technology is what is happening right now with all those new energies, as we call them. So new energy sources for aircraft, and I'm talking about hydrogen or sustainable aviation fuels, biofuels or synthetic fuels. I'm talking about electric or hybrid electric aircraft and so on. And that's a space where, things are moving relatively slowly, because this kind of transition is very difficult because of the energy density. However, it's an effort that it's worth doing, and I think we're going to see the results of this effort in the coming decade or so.
So what's the future with electric?
Well, electric has a specific particularity. It needs batteries, and batteries are heavy. So we see lots of applications for electric, but my expectation is to see electric planes flying in regional settings, so in short haul, but that's already a pretty big improvement.
So to pivot a little, you co-chaired the data management and machine learning design subgroups of the SAE G34 and Euro CAE WG114, did I pronounce that right? The Joint International Committee for the Certification of Artificial Intelligence-Based Technologies in Aviation. Could you tell us more about the challenges and considerations when it comes to certifying AI-based technologies for aviation? And how does this impact the safety and reliability of aviation systems?
Right. Okay. I'm going to start with a question. Let's say that you board an aircraft and, you fly somewhere and then the captain makes an announcement. And the captain says, well, good morning. Welcome to our flight to XYZ. Today, our plane is not inspected by a human operator, inspected by an algorithm. And my question to you is, would you board this plane and would you fly with a plane that basically no human operator has inspected its different mechanical systems? So, that summarizes the work we do there, basically. What we try to do there is to develop the standards and the practices and the mechanisms that can assure that AI can be implemented in critical aviation systems in a way that is trustworthy and can be certified. And I'm talking about maintenance, I'm talking about traffic management, and the dot in the horizon, it's also autonomous operations. For example, replacing one of the two pilots by some kind of algorithm, AI-based algorithm. So in that sense, that's a very thorough job that you need to do, and also a very responsible job that you should do. And because of that, we brought together a whole industry. We brought together people coming from the manufacturers, people coming from airlines, people coming from academia, people coming from the regulators. And we work for 4 years now, and hopefully next year the standard will be out, and the standard then can be adopted by the regulators. So we will be able to certify AI in a way that we can trust. And of course, the first steps might be not that flashy. The first steps might be a bit, the first application might be some small maintenance applications, but in that case, those applications will be running autonomously without any human intervention. And of course, by building trust ourselves to the standard and also the public to the algorithms, then we can proceed. Because one thing is the trust and the standard itself and how us we develop it, but also the public needs to understand and needs to feel comfortable with those technologies and trust those technologies, their lives with those technologies. That's the big question here.
That sounds highly complex. Can you share any insights into the collaboration and coordination efforts required between industry stakeholders, regulators, and technology developers to create certification standards for AI-based technologies in aviation?
Yeah, it's a very complex process indeed. In fact, the working group involves 500 people from all around the globe, and we work for 4 years so far, and we have at least 1 year before we have the standard. So you can imagine that that involves lots of coordination, also meetings in weird times of the day because everyone needs to be present. But I think it's worth the effort. So we are organized in different subgroups, and each subgroup has their own scope. And I was very lucky to have co-chaired the data management subgroup and the machine learning design group. In those meetings, we have regular meetings with the people there, where we bring up every time topics for discussion, and based on those discussions, we form some kinds of opinions and some kind of practices that we think are the ones that we need to follow. And then we put those discussions into paper. So basically we write down what we discussed and that we think it's the way to go. And this then is up for debate, up for discussion. This document is discussed for a long time. We make the right amendments and so on. And at some point we adopt the document paragraph by paragraph. So this is the way we work. And then it takes time and effort. On top of that, basically, another thing that I'd like to add is, on top of what I just described, basically, we need people coming from all kinds of different sides of the industry. So we need people coming from, the operational side, so airlines. We need people coming from the design side, so aircraft manufacturers and aircraft component manufacturers, and also AI experts. So it's a complex work and with lots of stakeholders. But yeah, I'm very optimistic that in the end we're going to have a very good standard for the industry to adopt.
So pivoting to sustainability a little, sustainability is a significant focus in the aviation industry. How do you see the role of innovation and AI in achieving sustainability goals? And what are some specific initiatives or strategies that you've been involved in to promote sustainability?
Yes, sustainability right now, it's, I can say number one objective for the aviation industry. The aviation industry is a very difficult industry to decarbonize for one reason. Planes need to fly and planes need to be light enough to fly. So in that sense, the best thing we have right now in terms of energy density is fuel. And of course, fuel is bad for the environment. So in one hand, we need to reduce and at the same, in the end, eliminate fuel consumption and also make sure that the planes are light enough to fly. So if we replace fuel with something different, planes need to be light enough. So AI can play a very important role in this kind of discussion. First, because by using AI, we can optimize our daily practices, our daily operations. So we can use AI to optimize the routes that planes take. We can understand and get all kinds of insights about the way that fuel is consumed on board the aircraft and optimize here and there all kinds of small operational practices and have some quite good improvements in fuel consumption. And of course, AI these days is used in a very extensive way in designing aircraft. And basically, in the past, we used to have more traditional methods. We used to have physics-based methods. We used to have, and we still have to some extent, but also AI right now is at the core of the design methods for aircraft. And the aircraft that are being designed right now are the next generation aircraft that can work with different fuels, can work with sustainable aviation fuel, and so on. So AI is first of all part of the operational improvement process, but also in the design process of new products.
And what role do innovations like electric aviation play in this context of sustainability?
Yes, electric aviation or hydrogen can be used in different ways, like directly combusted or with fuel cells, which is also electric aviation. I think the role is basically very, very, very important in decarbonizing aviation. We won't have results tomorrow. I expect to have results in the next decade for both electric and hydrogen. But yes, I think the most important challenge here is how we can scale up production of hydrogen, how can reduce the weight of batteries, and how we can make those systems fit within, first of all, the aircraft itself, and second, those aircraft fit in the existing operational requirements that we have at the airports and infrastructure in general.
Speaking of this in extension, simulation methods and digital twins are integral in aircraft design and maintenance. Can you elaborate on the importance of simulation methods and digital twins in the aviation industry as a whole, and how do they contribute to efficiency and safety?
Yes, that's a very good question. If you see an airline microscopically, from above, it's a huge optimization problem, basically. You need to optimize everything in an airline and at the same time provide scheduling, provide rostering, so basically things need to come together. And right now, the way that we approach those kinds of issues is that we optimize independently all those different parts of an airline or in aviation in general, but we don't optimize things combined, or at least to a less extent. So in that sense, by developing digital twins that could combine different parts of the organization and at the same time visualize the impact of this kind of, for example, some kind of operational disruption, we can have some really good results because, first of all, people can see what is the operational status of an organization. Second, by using AI in the digital twin, we can predict different scenarios about how the operations will evolve and which direction they can take, or simulate all kinds of scenarios about what can happen if we have some kind of disruption. And this way we can improve passenger experience, because you can imagine that if your flight is cancelled, you are frustrated, then we need to act quickly on that. And at the same time, of course, by bringing together all kinds of different operational parts of the organization, like of an airline, of the whole aviation industry sometimes. So think about the traffic management, combined operations, things like that. We will be able to optimize the ways we work, also make sure that people understand what is the situation, the status of a specific operational part, and take the right actions.
So what are the key challenges that aviation faces in adopting these digital twins more widely? And how can these challenges be overcome?
Well, yes, digital twins is a very up-and-coming and very nice technology, but of course there are always challenges. First of all, I'll start with the fundamental, which is data. So data is something that needs to be there, needs to be available, and it needs to be also curated in a way that those twins can consume. And that's not always in place, because we see not just in airlines, but in general, again, in aviation, data are coming from all kinds of different directions. So data curation is very important, and data quality is very important. So I think that's one of the first challenges, how you can use and source data in a good way. That's one thing. Also, data are protected by, most of the time, but all kinds of intellectual property rules and laws and agreements. Data can also be protected by agreements with regards personal data, pilot data, those kinds of things are present. So if we start with the fundamentals, I think bringing together data in a way that can facilitate the development of digital twins is a very important step. That's step number one. Then, of course, you need some, let's say, algorithms and some methods that can consume those data and that can provide predictive capabilities, if we talk about prediction. And that's the second step. And of course, I talked before about combining different parts of the operations, and those operations are not always run by the same organization. Think about airlines and airports, for example, or traffic management. So bringing together different organizations and develop products together, it's also a challenge. We are talking with different parties and stakeholders right now on how we can collaborate and coordinate on developing this kind of simulations. It takes time, but I see the value, and I think everyone sees the value. So in the end, again, I'm optimistic that the whole industry will come together and develop products that can enhance, first of all, operational organization that can come together and bring operational efficiency, and at the same time sustainability, and at the same time less disruptions. That's possible by developing the right digital twins in the future.
So the last question for you is of a personal kind. What would you be doing in your life if not this right now?
Well, frankly, I'm very, very passionate about what I do now. So, for me, what I do is, the best possible options. And if not, I think if not aviation, that could have been space. I like space a lot too. And I follow all the developments in the space domain as a hobbyist.